this piece of lead here. I want a piece of paraffin. It was just like that, with no advance warning and no conscious prior reasoning. I immediately took some odd piece of paraffin and placed it where the piece of lead was to have been, and before the day was over, the problem had been solved. Perhaps the most moving statement in this general context is that of Heisenberg, relating the moment when the laws of quantum mechanics came to a sharp focus in his mind. He has written, "One evening, I reached the point where I was ready to determine the individual terms in the energy matrix by what would be considered as an extremely clumsy series of calculations. But when the first terms seemed to accord with the energy principle, I became rather excited, and I began to make countless arithmetical errors. As a result, it was almost 3 o'clock in the morning before the final result of my computations lay before me. The energy principle had held for all terms, and I could no longer doubt the mathematical consistency and coherence of the kind of quantum mechanics to which my calculations pointed. At first, I was deeply alarmed. I had the feeling that through the surface of atomic phenomena, I was looking at a strangely beautiful interior and felt almost giddy at the thought that I now had to probe this wealth of mathematical structures nature had so generously spread out before me. I was far too excited to sleep, and so, as a new day dawned, I made for the southern tip of the island, where I had been longing to climb a rock jutting into the sea. I now did so without too much effort and waited for the sun to rise. There is no difficulty for any of us to share in Heisenberg's exhilaration of that supreme moment. We all know of the difficulties and paradoxes that beset the old Bohr-Sommerfeld quantum theory of the time. And we also know of Heisenberg's long puzzlement over these difficulties and paradoxes with Sommerfeld, Bohr, and Pauli. And Heisenberg had already published at that time his paper with Kramers on the dispersion theory, a theory which in many ways was a precursor to the developments that were to follow. But what is our reaction to Heisenberg's account of his ideas on the theory of elementary particles that he developed some 30 years later, after his tragic experiences during the war and his disappointments and frustrations of the post-war years? One moonlight night, we walked all over the Hainberg Mountains, and he was completely enthralled by the visions he had, trying to explain his newest discovery to me. He talked about the miracle of symmetry as the original archetype of creation, about harmony, about the beauty of simplicity and its inner truth. And Mrs. Heisenberg quotes from one of Heisenberg's letters at that time. In fact, this is Heisenberg's letter. In fact, the last few weeks were full of excitement for me, and perhaps I can best illustrate what I have experienced through the analogy that I have attempted an as yet unknown ascent to the fundamental peak of atomic theory with great efforts during the past 5 years. And now, with the peak directly ahead of me, the whole terrain of interrelationships in atomic theory is suddenly and clearly spread out before my eyes. That these interrelationships display in all their mathematical abstraction an incredible degree of simplicity is a gift we can only humbly accept. Not even Plato could have believed them to be beautiful, for these interrelationships cannot be invented. They have been there since the creation of the world. You will notice the remarkable similarity in the language and in the phraseology of this description with the description of his discovery of the basic rules of quantum mechanics some 30 years earlier. But do we share in his vision in the same way? In the earlier case, his ideas won immediate acceptance. In contrast, his ideas on particle physics were rejected and repudiated even by his longtime critic and friend Pauli. But it is moving to read what Mrs. Heisenberg writes towards the end of her biography. With smiling certainty, he once said to me, "I was lucky enough to look over the good Lord's shoulder when he was at work. That was enough for him, more than enough. It gave him great joy and the strength to meet the hostilities and misunderstandings he was subjected to in the world time and again." A different aspect of the effect a great discovery can have on its author is provided by the autobiography entitled The Traveler by Hideki Yukawa. The book was written when Yukawa was past 50. One would normally have expected that an autobiography entitled The Traveler by one whose life, at least as seen from the outside, had been rich and fruitful, would be an account of his entire life. But Yukawa's accounts of his travels ends with the publication of his 1934 paper when he was 27, describing his great discovery with the somber note, "I do not want to write beyond this point, because those days when I studied relentlessly are nostalgic to me. And on the other hand, I am sad when I think how I have become increasingly preoccupied with matters other than study." While all of us can share in the joy of the discoveries of the great men of science, we may be puzzled by what those many, very many, less perceptive and less fortunate are to cherish and to remember. Are they, like Vladimir and Estrangon, destined to wait for Godot, as in Samuel Beckett's play? Or are they to console themselves with Milton's thought, "They also serve who stand and wait"? I now turn to the role which approbation and approval play in one's pursuit of science. The example of Newton voyaging through strange seas of thought alone is not one that any of us can follow. I have referred to Eddington's lonely efforts in pursuing his fundamental theory. In spite of his expressed confidence in the correctness of his theory, Eddington must have been deeply frustrated with the neglect of his work by his contemporaries. This frustration is evident in the plaintive letter he wrote to Herbert Dingle a few months before he died. "I am continually trying to find why people find the procedure obscure, but I would point out that even Einstein was considered obscure, and hundreds of people have thought it necessary to explain him. I cannot seriously believe that I ever attained the obscurity that Dirac does. But in the case of Einstein and Dirac, people have thought it worthwhile to penetrate the obscurity. I believe they will understand me all right when they realize that they have got to do so, and when it becomes a fashion to explain Eddington." The lack of approval by one's contemporaries can have tragic consequences when they are expressed in the form of sharp and violent criticisms. Thus, Ludwig Boltzmann, greatly depressed by the violence of the attacks directed against his ideas by Oswald and Mach, committed suicide as a martyr to his ideas, as his grandson Flamm has written. And George Cantor, the originator of the modern theory of sets of points and of orders of infinity, lost his mind because of the hatred and the animosity against him and his ideas by his teacher Leopold Kronecker. And Cantor was confined to a mental hospital during the last many years of his life. A case of a very different kind from the ones I have considered so far is that of Rutherford. Consider his record. In 1897, he analyzed radioactive radiations into 3 groups and called them alpha particles, beta rays, and gamma rays, a nomenclature that continues to this day. In 1902, he formulated the laws of radioactive disintegration, the first time a physical law was formulated in terms of probability and not certainty, a forerunner of the probability interpretation of quantum mechanics that was to become universal 25 years later. In 1905 to 1907, he formulated, together with Soddy, the laws of radioactive displacement and identified the alpha particle as the nucleus of the helium atom, and together with Boltwood, initiated the determination of the ages of rocks and minerals by their radioactivity. In 1909 to 1910, there were the experiments of Geiger and Marsden, the discovery of the large angle scattering of alpha rays, and Rutherford's formulation of his law of scattering and the nuclear model of the atom. Then in 1917, he effected the first laboratory transformation of atoms, that of nitrogen-14 into oxygen-17 and a proton by alpha ray bombardment. In the 20s, Rutherford was associated with a clarification of the relationship between alpha ray spectra and gamma ray spectra. In 1932, the annus mirabile, as R.H. Fowler called it, saw the discovery of the artificial disintegration of lithium into 2 alpha particles by Cockcroft and Walton, of positrons in cosmic ray showers by Blackett, and the neutron by Chadwick, all of them in Rutherford's Cavendish. In the following year, Rutherford, together with Oliphant, himself discovered the hydrogen isotope of mass 3 and the helium isotope of mass 3. Altogether then, an accomplishment unparalleled in this century. Rutherford's attitude to his own discoveries is illustrated by his response to a remark of one of his colleagues who was present at the moment of one of his great discoveries. Rutherford, you are always on the crest of the wave. To which Rutherford responded, I made the wave, didn't I? Somehow, from Rutherford's vantage point, everything he said seems right, even including his remark, I do not let my boys waste their time, when he was asked if he ever encouraged his students to study relativity. Rutherford was a happy warrior, if ever there was one. So far, I have tried to illustrate some facts. I have tried to illustrate some facets of the pursuit of science by drawing on incidents in the lives of some great men of science. I shall turn now to some more general matters. I shall start with an example. It has been reported that when Michelson was asked towards the end of his life why he had devoted such a large fraction of his time to the measurement of the velocity of light, he replied, "It was so much fun." There is no denying that fun does play a role in the pursuit of science. But the word fun suggests a lack of seriousness. Indeed, the Oxford Dictionary gives to fun the meaning drollery. We can be certain that Michelson did not have that meaning in his mind when he described his life's main interest as fun. If not, what precisely is the meaning we are to attach to fun in the context in which Michelson used it? More generally, what is the role of pleasure and enjoyment? While pleasure and enjoyment are often used to characterize one's efforts in science, failures, frustrations, and disappointments are the more common ingredients of scientific experience. Overcoming difficulties undoubtedly contributes to one's final enjoyment of success. Is failure then a purely negative aspect of the pursuit of science? A remark of Dirac's describing the rapid development of physics following the founding of the principles of quantum mechanics in the middle and the late 20s is appropriate in this connection. Dirac has written, "It is a good description to say that it was a game, a very interesting game one could play. Whenever one solved one of the little problems, one could write a paper about it. It was very easy in those days for any second-rate physicist to do first-rate work. There has not been such a glorious time in physics since then." Consider this remark of Dirac in the context of what J.J. Thomson, in his assessment of Lord Rayleigh, said in his memorial address in Westminster Abbey. There are some great men of science whose charm consists in having said the first word on a subject, in having introduced some new idea which has proved fruitful. There are others whose charm consists perhaps in having said the last word on the subject, and who have reduced the subject to logical consistency and clearness. I think by temperament, Lord Rayleigh belonged to the second group. This assessment of Rayleigh by J.J. Thomson has sometimes been described as double-edged. But could not one conclude, instead, that Rayleigh, by temperament, chose to address himself to difficult problems and was not content to play the kind of games that Dirac describes in his characterization of the glorious time in physics as a time when second-rate physicists could do first-rate work? This last question concerning Rayleigh's temperament raises the further question. After a scientist has reached maturity, what are his criteria for his continued pursuit of science? To what extent are they personal? And to what extent are aesthetic criteria, like the perception of order and pattern, form and substance, relevant? Are such personal criteria exclusive? Has a sense of obligation a role? I do not mean obligation with the common meaning of obligation to one's students, one's colleagues, and one's community. I mean rather obligation to science itself. And what indeed is the content of obligation in the pursuit of science for science? Let me finally take a different aspect. G.H. Hardy concludes his A Mathematician's Apology with the following illuminating statement. The case for my life then, or for that matter, of anyone else who has been a mathematician in the sense in which I have been one, is this: that I have added something to knowledge and helped others to add more, and that these somethings have a value which differs in degree only and not in kind from that of the creations of the great mathematicians or of any of the other artists, great or small, who have left some kind of memorial behind them. Hardy's statement is made relative to mathematicians, but it is equally applicable to all scientists. I want to draw your attention particularly to Hardy's reference to one's wanting to leave some kind of memorial, that is, something that posterity may judge. To what extent, then, is a judgment of posterity, which one can never know, a conscious motivation in the pursuit of science? The pursuit of science has often been compared to the scaling of mountains, high and not so high. But who amongst us can hope, even in imagination, to scale the Everest and reach its summit when the sky is blue and the air is still, and in the stillness of the air, survey the entire Himalayan range in the dazzling white of snow stretching to infinity? None of us can hope for a comparable vision of nature and of the universe around us. But there is nothing mean or lowly in standing in the valley below and awaiting the sun to rise over the Kanchenjunga. Thank you.
Thank you very much, Professor Chandrasekhar.